Welcome you all to formation of aliphatic carbon-carbon bonds using acid as catalyst. In this model, so far we had one lecture in that we studied about the reactions of alkenes, aldehydes and ketone. In this lecture, we will study about the Mannich reaction. It involves the reaction of amine, aldehyde to give a iminium ion, which undergoes addition reaction to give beta amino derivatives. For example, in this case, the secondary amine undergoes reaction with the formaldehyde to give iminium ion, which leads to addition reaction with this enolizable ketone to give this beta amino carbonyl compound as the product. The mechanism of this transformation shown here, protonation of the carbonyl group of formaldehyde can give this species which is more electrophilic in nature comparing to formaldehyde. Once you form this, which can undergo addition with this amine to give addition compound, which can lose a proton to give this amino alcohol as a product. Since we carry out the reaction in the presence of catalytic amount of acid, and protonation of the hydroxy group can give this hydronium ion species, which can lose a water molecule to give this iminium ion, which acts as electrophile in Mannich reaction. Since the reaction is acidic in nature and this carbonyl compound can undergo protonation with this acid, and you will have the species. Once you form this one, this can lose a proton to give this enol. This can now undergo addition with this iminium ion that we formed from the reaction of formaldehyde and secondary amine to give this addition product. Once you have this addition product, that can lose a proton to give this beta amino carbonyl compound as a product. What you do here, you generate two bonds, one carbon-carbon bond between this carbon and this carbon of this iminium salt. In addition to that, you also form a carbon-nitrogen bond from the carbon of formaldehyde and nitrogen of amine. So, basically you form carbon-nitrogen, carbon-carbon bond to give this beta amino carbonyl compound as a product. This is three component reaction. As you can see here, the reaction of amine, aldehyde and enolizable aldehyde are involved to give this amine beta amino carbonyl compound as the product. Now, let us look at what kind of amine, what kind of enol derivatives can be used for this reaction. If we use primary amine, for example, it can undergo reaction as we have seen earlier with the formaldehyde to give the corresponding iminium salt. As electrophile, which can now react with enolizable ketone For example, you will get, if you use this ketone which can undergo addition reaction, you will get this compound as the product. So, this also this is a secondary amine which can further undergo reaction with another molecule of formaldehyde. You form this iminium salt, which can further react with this enol to give this addition product. It involves double two Mannich reactions sequentially. First, the primary amine reacts with the formaldehyde, you form an iminium salt, which undergoes addition reaction with the enol that is formed from this ketone to give a secondary amine as the product, which can further react with another molecule of formaldehyde and which can give this iminium ion as electrophile, which can lead to addition with this enol that we can generate from this ketone to give this as a product. So, if you have primary amine, you need two equivalent of formaldehyde and enolizable ketone to get this derivative. You can also use ammonia in place of primary or secondary amine. As we have seen earlier, this ammonia now can react with the formaldehyde. You will be able to form this iminium ion as electrophile. Once you form this one, this can react with this enol. You will be able to get this primary amine as a product. Once if you have this amino derivative, which can further react with another molecule of formaldehyde, you will be able to generate this kind of iminium ion, which can further react with this enol that we generate from this ketone. Addition reaction, you get this secondary amine derivative, which can further react with another molecule of formaldehyde, which can give iminium ion as a salt, which can undergo further reaction with this enol that we can generate from this ketone to give this tertiary amine derivative as the product. So, if you look at here, and in this case you produce two water molecule as the product. When you do condensation of this amine with formaldehyde, you generate one molecule of water and iminium salt, which undergoes addition reaction with the enol. And similarly, that whatever secondary amine which can undergo reaction with this formaldehyde, by condensation you will generate another molecule of water. That iminium ion can undergo reaction to give this. So, in this case you will be able to generate 3 water molecule. You need 3 equivalent of formaldehyde and this ketone, therefore, you will be able to make this tertiary amine derivative as the product. Now, let us look at what kind of substrate can undergo addition reaction with these imines that we generate from the aldehyde and amine as electrophile. If you have enolizable aldehyde, for example, here we have taken isobutylaldehyde. In acidic medium, it can form enol. So, if you have, for example, in this case the reaction, all the reaction use formaldehyde and dimethylamine. So, this can undergo reaction now, since you carry out the reaction in the presence of catalytic amount of acid. As we have seen previously, this formaldehyde now can undergo condensation with this dimethylamine. So, you will be able to generate this salt. Once you form the iminium ion, now this enol can undergo addition reaction, you will be able to form this compound. Similarly, you can also use ketone. Just we have seen this also can form enol. which can react with this iminium salt. So, you will be able to form this beta amino carbonyl compound as a product. You can also use, in place of aldehyde and ketone, you can also use this diester, which can also enolize in the presence of catalytic amount of acid. So, which can now undergo addition reaction, you will be able to form this compound. 2-methylpyridine also can enolize, that can undergo reaction with this salt that we generate from formaldehyde and dimethylamine. When you have acid, you can generate this intermediate. Once you form this one now, which can undergo addition reaction, you will be able to generate this amino derivative. (4-methylpyridine), (2-methylquinoline), and 4-methylquinoline can also readily undergo addition reaction with this iminium ion that we generate from aldehyde and amine selectrophile. So, these are the compounds which can form enolate enols that can undergo addition with this iminium salt to give the addition product. In addition to that, beta naphthalene also can undergo reaction with this iminium salt. If we have this iminium salt, it can undergo addition, you will be able to generate this intermediate, which can lose a proton to give this addition product. You can also try to use furan, pyrrole, indole based derivatives. For example, in this case, so you will be able to generate 3 substituted indole this amine derivative as a product. So, in addition to that, acetylene also can undergo addition reaction with this iminium salt to give the addition product. Although acetylene cannot form enol, however, it can undergo Mannich reaction to give this amine derivative as a product. The reaction so far we have seen where we use acid as catalyst to generate the iminium ion, that leads to addition reaction with these compounds that can form enols to give the addition product. We can also try to make the iminium salt by substitution react. For example, here you can react acid chloride with this amine, you can form this salt. Once if you have the salt which can lose this amide to give this iminium salt, which we can use as electrophile. In addition to that, we have tertiary amine, we can try to react with the diiodomethane to give this quaternary ammonium salt, which can, when you heat at 150 degrees Celsius, can lose methyl iodide, can give this iminium salt, which can be used as electrophile in this addition reaction. So, in this reaction, this reacts with this diiodomethane via SN2 pathway. You form this quaternary ammonium salt. Once you form this one, this can further react via SN2 pathway to give this iminium ionosus product. So, this can readily react with this 2-methyl cyclopentanone to give this addition product. So, if you can make this iminium salt, you can carry out this addition reaction in the absence of acid to give this manic product. So far, we have seen the nature of the amines as well as the carbonyl compounds that can be used for the manic reaction. Then we also have seen this formation of iminium salt, that once you form this salt, that can be readily reacted with the inological compound in the absence of acid to give the manic product. So, in this case, in the absence of acid, you can try to generate less amount of enol, since the reaction exists in equilibrium. As soon as you form the enol, which can undergo reaction with this iminium salt, you can give the addition product. Here the application of the manic product for the formation of alpha beta unsaturated compound is shown here. Reaction of formaldehyde with dimethylamine in the presence of catalytic amount of HCl can give this salt, which can undergo reaction with this enol. You can get this manic product. Once you have this one, you can react with methyl iodide, you will be able to generate a quaternary ammonium salt. Once you form this one, this salt, when you react with base, the base can deprotonate this acidic proton which can lose trimethylamine to give this alpha beta unsaturated carbonyl compound. This can be further reduced to give this methyl ethyl ketone. If you do hydrogenation using palladium charcoal, and you will be able to get the reduced compound. In addition to that, this methyl vinyl ketone is very important substrate we use as precursor for the Robinson annulation, several other reactions. If you have acidic medium, the cyclohexanone can undergo enol formation. Once you form the enol, which can react with this double bond to give the addition product. Once you have the ketone, now this can undergo enolization to give this enol, which can lead to addition reaction with this carbonyl group, which can be activated using this proton. You will be able to have this can now undergo protonation. We have acid, so when you have acid, it can undergo protonation to give so which can lose water molecule. You will be able to generate this carbocation, which can lose the proton. You will be able to get this as the product. So, here first this whatever enol we generate from this 2-methyl cyclohexanone, which undergoes Michael addition, 1,4 addition. Once you form the addition product, that can further undergo enol formation, the presence of acid. That enol which you generate from this carbonyl group can undergo addition reaction to give the aldol product, which can undergo dehydration to give the alpha beta unsaturated carbonyl compound. It involves Michael addition followed by aldol condensation, which can be carried out using acid as catalyst. If you look at this, involves the methyl vinyl ketone as a starting material to construct this compound. Now, let us look at some more examples. We have cyclohexanone, as we have seen earlier. You can also try to make the corresponding this alpha beta unsaturated carbonyl compound. The reaction of formaldehyde with dimethylamine in the presence of HCl can generate this salt, iminium salt, which can undergo reaction from the enol that we generate from the ketone. Addition reaction, you will be able to form the Mannich product. Once you form this one, you can try to react with methyl iodide, you form quaternary ammonium salt. When you react with the base, it can deprotonate this acidic proton, then it can lead to elimination to give this methylene compound as the product. Similarly, if you have this unilysable ketone, which can also react with the formaldehyde in the presence of HCl with this secondary amine to give this Mannich product. Once you form this one, which can be reacted with methyl iodide to give the quaternary ammonium salt. So, if you have base, you can deprotonate this acidic proton, it can eliminate this amine, you can generate this phenylvinyl ketone as a product. These conjugated alkenes are very reactive. Whenever you required, you can try to react using base, and you can convert into the unsaturated carbonyl compound you can use for the organic transformations. So, now let us look at the other applications. The Mannich base also can be further converted into other useful compound. Here is shown here, when you react this Mannich base with the dimethyl sulfate, you can generate this quaternary ammonium salt. Once you form this salt, which can be reacted with nucleophile like cyanide ion via SN2 pathway to give the nitrile compound. As a product, in this reaction, it has been further converted into carboxylic acid by hydrolysis. So, if you have nitrile compound, you can convert into carboxylic acid by acid hydrolysis. Proton transfer can give so this can further undergo reaction with another molecule of water. Will be having this intermediate, again proton transfer. You can lose one proton and add another proton here. So, once if you do it, you will be able to have this intermediate. This can easily remove, you will be able to this can lose a proton, you will be able to generate the carboxylic acid. This is how you can do hydrolysis using acid, you can readily convert the nitrile to carboxylic acid. Another example, if you have indole, it can be readily converted into amino acid. here the synthesis of this amino acid shown here. You can react the indole with iminium salt that you can generate from dimethylamine formaldehyde. You can make this mannich product. Once you form this one, you can try to react with this nucleophile. This can be easily formed from this reacting with the base, which can react with this ammonium salt via SN2 pathway. You will be able to produce this compound. When you do base hydrolysis, the acetyl group can be hydrolyzed to amine and carboxylic acid. Then you can also carry out hydrolysis of the ester and you can get the amino acid. This can be easily, when you have this amide, you can react with the base. So, you can in this way you can try to produce the amine, you can deproduct this acetyl group. Acid hydrolysis, if you have ester, you can try to do hydrolysis using acid, you can generate the carboxylic acid as a product. And once you generate the dicarboxylic acid, that can be further converted into monocarboxylic acid via decarboxylation. If you heat the dicarboxylic acid in acidic medium, it can undergo decarboxylation to produce this amino acid as a product. Here an example shown for the synthesis of alkaloids. Here the reaction of this dialdehyde with this primary amine and this carbonyl compound is shown. It can, when you mix all three together and leave it in acidic medium for 3 days, they undergo double Mannich reaction to give this bicyclic ketone as a product. In this reaction, the primary amine, as we have seen earlier, can react with this aldehyde. Since the reaction medium is acidic in nature, it can undergo condensation to produce this salt, which can act as electrophile, which can undergo reaction with this enol form of this carbonyl compound. You will be able to generate this addition product. Once you form this one, which can undergo an acidic medium, can undergo condensation to give this iminium salt. So, this iminium salt can undergo reaction with this enol form to give this addition product. You will get the bicyclic compound. Once you form this one, which can lose carbon dioxide to give this bicyclic ketone. Already we have seen the last class, if you have carboxylic acid and it can react in acidic medium when you heat, you can lose carbon dioxide to give this enol that can convert into ketone. So, here if you look at it here, this primary amine undergoes reaction with this dialdehyde. First undergoes condensation with one of the aldehyde, which can undergo addition reaction from the enol that you can generate from the carbonyl compound. You will have this intermediate. Once you form this intermediate, that can undergo further intramolecular condensation to form this iminium salt. Once you form this iminium salt, which can undergo enol intramolecular addition reaction from the enol that you can generate to give this product, which can undergo decarboxylation sequentially to give this bicyclic ketone as the product. So, it involves a double Mannich reaction. Once you form this one, this carbonyl group can be further reduced to alcohol. So, this alcohol has been reacted with this carboxylic acid to give this ester, which is known as atropine. This is used for a certain type of nerve problem, as well as it is also used as pesticide poisoning. So, other example, if you have just we have seen, if you have this dialdehyde, if you react with the corresponding carboxylic acid, you will be able to generate this bicyclic ketone. Here one of them is converted into ester. If you do the reaction as we have seen earlier with the primary amine in acidic medium, you will be able to generate this ketone as product by double Mannich reaction. Once if you form this one, this can be further reduced using appropriate reducing agent to give the corresponding alcoholous product, which can be further reacted with the carboxylic acid to give this ester as the product. Similarly, if you use this aldehyde, dialdehyde, you will be able to generate this bicyclic ketone as the product. Here also what happens, the double Mannich reaction is involved. Following that, decarboxylation takes place to give this ketone. And if you look at all the cases, you have to use one equivalent of this dialdehyde and one equivalent of this primary amine and this carbonyl compound. You will generate 2 molecules of water as a byproduct. So, since the reaction it involves a double Mannich reaction, you will generate 2 molecules of water as a byproduct. So, here another example shown here. In this case, the reaction of secondary amine and formaldehyde and this ketone is involved. As we have seen earlier, the reaction of this amine with this formaldehyde can generate the iminium salt, which can undergo reaction with this enol that you can generate. It can undergo addition reaction. You can get this addition product, which can be reduced using reducing agent to give the alcohol. This can be further reacted with the acid to give this ester as the product. The other application is the synthesis of spatine. This secondary amine, cyclic amine can be reacted with formaldehyde. You have to use here 2 equivalent of formaldehyde and 2 equivalent of amine with 1 equivalent of acetone in the presence of acetic acid, and you will be able to generate this addition product, which also involves double Mannich reaction. So, once if you form the iminium salt, this can undergo addition reaction. Will generate this additional product. Once you form this one, then this ketone can be converted into enol that can further react with this iminium salt. You can get this addition product. Once you form this one, this should be green color. Both this and this are coming from the secondary amine, and this blue color comes from the acetone, and this comes from the formaldehyde. Once you form this one, when you react with this mercury acetate, you will be able to generate the imine salt. Once you form the imine salt, now that enol what you generate from this ketone which can undergo addition reaction with this, you will be able to form this intermediate, which can further undergo enol formation. So, you will be able to generate this compound, carbonyl compound. Once you form this one, you can reduce the carbonyl group to give this spartine as the product. This is Wolff-Kishner reduction. So, when you have the carbonyl compound, when you do condensation with the hydrazine, you will be able to form hydrazone, so this can react with base. Deprotonation of this proton can form this ion, which can give this intermediate which can further react with base. Deprotonation can give water plus ion which can convert it into so further it can abstract the proton from water. So, using hydrazine in the presence of base, you can try to reduce the carbonyl compound into hydrocarbon. This is the mechanism. It is a well known reaction. It can easily transform ketone to hydrocarbons. So, this slide shows some of the examples. Here the reaction of this secondary amine with formaldehyde is shown, which can undergo condensation to give the iminium salt. Once you form this one, which can now undergo intramolecular cyclization to give this addition compound. This another interesting example. Here this aldehyde can react with this amine, secondary amine, to give the iminium salt. Once you form this one, this can undergo addition reaction. To give this product. Here an example shown for the enhanced selective synthesis of the Mannich product. In the presence of L-proline, the reaction of acetone can be carried out with 4-nitrobenzaldehyde and this aniline derivative to give this addition product. If you replace the acetone with this carbonyl compound, and if you change the aromatic to aliphatic aldehyde, isobutylaldehyde, you can also try to react with this aniline derivative to give the addition product. When you use this substrate, the enantiomeric excess is reduced to 65%. These are some of the examples for the recent developments in Mannich reaction. The Mannich reaction is one of the powerful organic transformations which can be extensively explored, and these are some of the examples you can see here. So, let us make summary. First, we have seen the mechanism of the original Mannich reaction. Following that, the type of substrate that can undergo Mannich reaction we have seen. You can use primary, secondary amine or ammonia. They can undergo sequential Mannich reaction. For example, if you use ammonia, it can react with 3 molecule of formaldehyde and other nucleophile. You can get the addition product. You can the amine should be ammonia, primary or secondary amine. Similarly, you have to use aldehyde. You can use in the place of formaldehyde other aldehyde also, which should not undergo enol formation. The condensation takes place. You can form the imine salt, which acts as an electrophile, which undergoes reaction with variety of reactant we have seen. We have seen the reaction of aldehyde, ketone, beta naphthol and other related compounds. You can also try to react with 2-methylpyridine. It can readily undergo addition reaction to give this beta amino derivative as a product. Then also we have seen how you can convert the Mannich base into variety of useful compounds. If you have the Mannich base, you can try to react with further alkyl halide, for example, methyl iodide. You can make quaternary ammonium salt. Once if you form the salt, you can try to react with the base and you can do elimination. You can get the alpha beta unsaturated carbonyl compound, which we use as a reactant for variety of organic transformations. These alpha beta unsaturated carbonyl compounds are very reactive. Therefore, whenever you need, you can try to make it and you can do the further transformation. For example, we have seen the formation of methylvinyl ketone. You can make it, you can use we use that compound for the Robinson annulation. You can do Michael addition followed by aldol condensation to get the bicyclic carbonyl compound. Then also we have seen the application for the alkaloid synthesis. We have seen several examples there, and you can try to keep the reaction condition below pH 7 acidic medium, then it can undergo multiple manic reaction to give interesting bicyclic compound. We have seen variety of applications there, and you can also we also have seen how you can react the manic base with nucleophile. For example, if you have indole, you can do manic reaction. Further, you can react with appropriate nucleophile. You can convert into amino acid. These are some of the important applications. Later, we have also seen you can use chiral catalyst. You can end up with optically active manic base as the product, which can be further used for the variety of construction of variety of optically active organic compounds. With this, we conclude this lecture. Thank you very much.